Now we're going to look at systems of equations and we're going to solve them by graphing. This is not the best method for solving, but it does give you an idea of what's going on, and if you're stuck with the other methods, it might at least give you an idea of what the solution looks like, so kind of get you in the ballpark. The problem with solving by graphing, especially if you're graphing by hand, is it's not very precise. So unless you're on graph paper with a ruler, it's probably not going to be great. But we're also going to look at how to do this with a graphing calculator after we look at graphing them by hand. Okay, so we're going to do that at the end. All right, so the idea here is that we have a system of equations. So let's say we have 2x minus y equals 3, and we have 2x plus y equals 5. All right, and we want to solve this by graphing. So we're going to graph this, and to do that, we want to get these in slope-intercept form would be the easier way to graph it. So I'm going to take 2x minus y equals 3, and I'm going to put this in slope-intercept form, which means get y by itself. So I'm going to move the 2x over, so I do the opposite, which is minus 2x. And I can't put the 2x and the 3 together, so I'm just going to have negative 2x plus 3. I'm going to put the x term out front because that is what slope-intercept form looks like. And now I have negative y equals this, so I want to multiply, I want positive y here, so I want to multiply through everything by a negative. So I'm going to multiply everything by a negative or negative 1, and that's going to change all of the signs in the equation. So I'm going to get positive y, positive 2x, negative 3. Okay, so our system of equations is going to become, for the first one, is y is equal to 2x minus 3. Okay, so I rewrote the first equation, and I'm going to do the same thing for the second equation. So I've got 2x plus y equals 5. And again, I want to get the y by itself, so I'm going to move the 2x over. And that is going to give me negative 2x plus 5. So I've got y equals negative 2x plus 5. I've got the y by itself. I don't need to change the sign, so that one is good. Okay, so we got the two equations into slope-intercept form. I'm going to go ahead and erase our work here. You would keep that on your paper, though. Okay, so we rewrote these. Now, we're going to talk about parallel lines here in just a minute where they have the same slope. So one thing that I want you to notice is right here, it might be tempting to say that these are parallel lines because the number in front of the x is the same. But remember, this is not in slope-intercept form, so these are not the slope. So you can't say it there. You have to get them in this form and then compare these numbers. Okay, are these the same number? No. One is positive 2, one is negative 2, so these are not parallel. Okay, so don't do it in this form over here. It's got to be y equals for you to be able to see the slope. So these are not parallel lines, so let's go ahead and graph them. Okay, so this one's going to have intercept negative 3. This one's going to have intercept 5. So I want to make sure my graph at least goes that big. Okay, so we can already tell my picture is not very straight here. Part of that's because I'm on a graphics tablet, so I'm kind of like drawing off to the side. It's different hand-eye coordination. So my pictures are always a little bit wonkier than they would be if I was actually drawing them by hand. So here's my graph. And to draw the first one, I'm looking right here. I've got y-intercept negative 3, so that means I start at negative 3 on the y-axis. So here, I'll go ahead and draw this one in red. So there's negative 3. And then, so let's go ahead and write that. B is negative 3, and my slope is 2, okay, or 2 over 1, which means I'm going to go up 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1. All right, so that's the first line. Let's try that again. Okay. Not perfect, but you get the idea. All right, and then let's do the other one. So the other one has a y-intercept 5 and slope -2. Okay, so y-intercept 5 means I'm going to start at 5. 1, 2, 3, 4, 5. And then slope -2 means, remember, we can put the negative with the top or the bottom of the fraction. So I can go down to right 1, or I can go up to left 1, depending on which direction I want to go to hit the other line. Okay, I want to hit the red line, so down to right 1 looks like it's going to hit the other line, so we'll do that. So down to right 1, down to right 1, down to right 1. Okay, so that gives us the other line. All right, now my drawing is probably even more of an exaggeration of how unreliable this is, but you should still see that when we counted our slope up and over, it looks like both lines hit this point at 2, 1. Okay, so I think that my solution is going to be the point 2, 1. Remember, the solution is the intersection point. So I think my solution is 2, 1. Graphing isn't terribly reliable, so I'm going to check it by plugging it into both equations just to be sure. You can plug it into the original, or you can plug it into the solved equation or the rearranged equation. I'm going to plug it into the original just in case I made a mistake here in the first step. Let's plug it into the original and make sure that it works there. Okay, so I check the first equation. I plug in 2 for x. I plug in 1 for y. So that's going to be 4 minus 1 is 3, so that looks good. And we check it in the second equation. So I'm going to plug in 2 for x and 1 for y, and that also looks good because 4 plus 1 is 5. Okay, so the graphing by hand gets you at least reasonably close to a solution, but because it's not reliable, I would go ahead and check it as well. Okay, so that's what it looks like to solve by graphing. All right, and like I said, most of our systems of equations are going to look like this, where you have one intersection point here that you're trying to find by graphing. So let's look at our two special cases just to see what those would look like. Okay, so let's say that we have the system of equations y equals 3x minus 2 and y equals 3x plus 5. All right, now I already got these in slope-intercept form for you, so we saved a step there. And from here, you should see immediately that they have the same slope. Okay, so they both have slope 3. We are in slope-intercept form here. They both have the same slope, which means they are parallel lines. All right, so let me erase that so we can keep working. Okay, so you should see that they're parallel lines. And you should remember that parallel lines have no intersection points. Okay, no intersection, which means no solution. Okay, so you should remember that from the last section. If you didn't and you just went ahead and graphed this, that's okay too, because you should see it on the graph, even if your graph isn't perfect. Okay, so we're going to put some notches on our graph here. All right, and we'll graph it the same way that we graphed before. So for the first one, we've got a y-intercept of -2, and we've got a slope of 3. Okay, so y-intercept of -2, and the slope of 3 tells us to go up 3 over 1. So up 3, right 1, up 3, right 1, and if you want, you can go one more time, something like that. Okay, so there's our first line. And then our second line has a y-intercept of 5 and a slope of 3. If you didn't notice it before, hopefully you notice it here. Okay, but if not, that's okay. 1, 2, 3, 4, 5. Sometimes we're just kind of in the groove doing our work, right? So we go up 3 over 1. If you want to draw it a little bit bigger, you can go up 3 over 1 again, or you can go down 3 back 1 to go the other direction. And we draw our line. Okay, now at this point, for sure, if you have not noticed the same slope, you have drawn your two lines and you think, these are definitely not intersecting on my graph here. So you have two options. You can draw a much bigger graph, maybe pull out your ruler, try to draw it a little bit more precisely and so on, or you come back up here and you notice that the slopes are the same. And you go, oh yeah, now I remember. Same slope means parallel lines, which means no solution. Okay, if they were not parallel, okay, if they looked like this and they were not parallel, you would either need to redraw them or draw a much bigger graph to get to the intersection point. If they're not parallel, they will intersect somewhere. You just might have to draw a bigger graph to get to it. I'm not going to give you any that intersect at like 100, okay, so they should intersect in a reasonable area to graph. Okay, so that's what it looks like if there are parallel lines. If you have a set of parallel lines, then there's no solution. Okay, let's look at the other special case. So the other special case would look like this. So we have, let's say we have 2x plus y equals 4, and we have y equals negative 2x plus 4. Okay, so the second one's already in slope-intercept form. The first one we're going to put in slope-intercept form. So we want to get the y by itself, so we're going to move the 2x. We do the opposite, which is minus 2x. Okay, so we get that in slope-intercept form, and we can rewrite our system as y equals negative 2x plus 4, and the second one's already done, y equals negative 2x plus 4. And at this point, you should suspect that something has happened. Okay, so you can't see it necessarily in the first set of equations, but in this set of equations, when you get in slope-intercept form, you should absolutely see that they are the same line. That means that they will intersect in all of their points, and that means that there are infinitely many solutions. Okay, so infinitely many solutions. So that's what it looks like for the other special case. And it kind of, when you put it in slope-intercept form, you're going to see that they're the same line. Okay, so you don't even need to graph that one. You know it's the same line. You know that it's going to intersect in every point, so it's infinite solutions. Okay, so that's what it looks like for our regular case and our two special cases. I'll put up a short video on how to graph using a graphing calculator if you want to try that. You don't have to use a graphing calculator. Everything that we do you should be able to do it by hand. So you don't need to, but if you want to, I'll put that up as well.